About kind of the basics of Hive and HBase today. There's a basic understanding that you guys have an understanding of the Hadoop ecosystem, or the basics of Hadoop and MapReduce. So the agenda for the presentation today is to basically cover stuff on Hive and HBase. On Hive side of things, we'll be covering brief introduction of Hive, a look at architecture, how it kind of compares to RDBMS, what are the data types, how do we, so we'll try to do some, practical kind of stuff, so we'll try to install and configure. I have things listed down in a slide and we can take it forward from there. We'll see what is the Hive QL and the Hive shell, and we'll do some basics of with the Hive shell basically. And also I'll be touching upon, because I mentioned it in the agenda, I'll be touching upon the two types of tables that Hive supports and what are the basic differences amongst them. We can then, we'll talk about who uses in the industry and what are the conclusions we can take from this. HBase is a different piece, so we'll be tackling it in the same way, but we'll be covering the NoSQL side of things, the basic architecture, how it's layered over Hadoop, how it compares to RDBMS also. The basic building blocks such as the H master and region servers and all that. Any code, NoSQL, it's a column-based source, so we'll be touching upon how data is kind of stored and organized in an HBase table. And then again, we'll try to see an example of HBase. So I'll start with Hive. Okay. So Hive basically, hello? Sorry guys, there was some disturbance. As I was speaking, Hive is basically a data warehousing framework built on top of Hadoop. When we say data warehousing, we are looking at all the things that a data warehouse is supposed to do, like query summarize, data summarization, ad hoc queries, and the ability to get data, query data from large data sets, make sense out of it. This was started at Facebook when Facebook was growing heavily, and they were around 300 million users in 2006, and they kind of built it there. Later it became an Apache top-level project. For any data warehouse, the target users are data analysts who want to churn there's a lot of disturbance here.
Hello.
Can guys, can you please mute yourself, because it's pretty difficult to proceed. I'll put it on the chat. Okay. It basically has a very there is a SQL-like shell called Hive QL, which is Hive query language. We'll see when we do the practicals, and it allows you to query data stored in Hive, which internally is stored in HDFS. Whatever we query, so all queries that we fire on the Hive QL are internally, basically abstracted as MapReduce jobs, and internally they Hive constructs MapReduce jobs of various complexities and executes it, and then brings the result back to us basically. As for any RDBMS kind of a store or a data warehouse store, this is basically meant for structured data. So you try to put structured data in Hive and try to query that. When I say structured, you basically mean that you know the schema up front and you are comfortable with what the schema is, unlike unstructured data where it can be sparse or it can be a lot of columns may not be there basically. So we'll go deeper and we'll see what we can do. Architecture wise, looking at this screen for long will not make sense, but what it tries to show is this is your Hive building, Hive layer, and this is your Hadoop HDFS layer. Basically, the ways you can interact with Hive is using a command line interface, which we'll see in practical. You can also interact using a web interface, and you can write programs to interact through JDBC ODBC, which in turn talks to the the RPC mechanism that Thrift provides. Basically, Thrift is basically an interface definition language which provides it's like a communication protocol. You can understand it like a communication protocol. So JDBC and ODBC internally use it to basically talk to the driver. We'll see on the next slide kind of a brief detail about each of these blocks. There is a meta store which is basically stores the metadata information of the tables and the data that we store in Hive. So we'll go ahead and we can try to come back and forth if we need. So as I said, we can interact with Hive using a command line interface, JDBC, ODBC, or a web graphical user interface where you can see all the tables and all that. Metastore basically shows the system data, the metadata about tables, columns, partitions, and all that. This data is generally stored in RDBMS itself. So with the default installation, there is a database called Derby that is basically an embedded database that comes packaged with the install. We don't need to do too much anything about it, as we'll see. And that Derby instance basically stores all the metadata for what the data you store in Hive. Now this is not like you have to conform to this. If you want to store this data in an external MySQL as a metastore, you can do that. So that's configurable basically through one of the configuration properties. The driver block, as we saw here, the driver block can be considered as taking care of compiling the queries, and it basically takes care of the entire query lifecycle. So the moment you execute a query and it gets, the driver basically takes it on from there, and it makes sure that that gets compiled by the compiler. The execution engine, which is kind of here not put separately, but it is a part of compiler, optimizer, and executor. So you can consider the executor as the execution engine. Basically, creates MapReduce jobs out of this compiled query, and basically makes tasks that HDFS or MapReduce framework will execute so that the query can execute. Hive server is not mentioned in the architecture diagram, but it basically means this part of the thing, where you have your Thrift server, and as I said, Thrift is an interface definition language or a protocol. So you can basically write clients and interact with Hive. So you can write a Java client, import the necessary libraries, and do things with Hive, like we do in JDBC with MySQL and all that. So maybe one layer of abstraction higher, one more layer of abstraction with Thrift. So now, when we are storing data in Hive, we need to create a warehouse directory basically in HDFS. This is not in the local directory, it is in the HDFS directory. So we create a user Hive warehouse directory, and this basically is our warehouse repository. And here on, whatever tables are stored as subdirectories. So suppose I store a table called test, it will be user/hive/warehouse/test. So as this line tells us. Sorry. The table row data is stored in subdirectories of warehouse. So test data will be stored in warehouse/test onwards. Now there's a concept called partitions in Hive. Partitions are nothing but, we'll be talking about partitions later, but to give you a brief, partitions are subdivisions of tables. So let's consider them subdivisions of tables for now. And partition data is stored basically as a subdirectory of the table directory. So if I have a partition on a date for say July, then July month I have a partition, then it will be like test/July. So all the data pertaining to July can be stored in the /test/July subdirectory. Why we do this and what's the use, we can see. We'll be seeing that later. The actual data that we are storing in this thing, in these subdirectories and directories are stored in flat files. They can be text files or they can be sequence files, as Hadoop supports both text and sequence files. Okay. There's not too much to bother about it, but I had mentioned it in the agenda, so I thought let me take it up. So Hive is actually not very good for query latency, basically, and latency for Hive query is very high even when the data set is small. When we say data set is small, it doesn't mean very minute data set, it means at least MBs of data. But then a normal RDBMSs will perform much better compared to Hive for a lot of that kind of data sets. And the other comparison is when you load data into Hive versus when you load data into RDBMS. So when you load data into your RDBMS like MySQL or something, if the data doesn't fit in the schema that you have defined for a table. Suppose we say load data in file from a text delimited file and we try to load it in a table, and the table schema is something else and there is a mismatch, you will get an error. You can't load that data. But Hive doesn't have a problem with that. So that's the RDBMS way of doing things is called schema on write. Basically, when you write data into a table, it kind of has a problem. RDBMS, what it does is it lets you write it, but when you query it, it will not throw errors, but it will show nulls in those fields. So there is a basic difference between how you can load data. So other than that, Hive is not designed for transaction-based or OLTP kind of queries or transactions, and it doesn't provide row-level updates and real-time queries unlike other RDBMSs. Basically, since it runs over a batch processing system like Hadoop or MapReduce, it is best suited for batch jobs over huge data and things that can be run in parallel. So, like weblogs, you can have data analysis over weblogs, huge kind of weblogs where you are ready to sacrifice some latency, but it's a batch job. So Hive is more suited for that. The supported data types are very similar to how we have in MySQL and other databases. We have a big int, we have a small int, we have a tiny int, we have an int. Integer types assigned. Basically, you can represent both minus and plus. We have like float and double, string, boolean. Oh, the other part about Hive is that you can also store the complex types like associative arrays. Associative arrays, people who are familiar with PHP will be knowing that it's like a map in Java. It's like a key value pair. Lists are lists in any language. And struct is basically a data structure, your custom data structure. So you can store these things also. You can define these types and you can play around with them. So we'll be looking at the basic types for the interest of simplicity and time. But we can kind of just provide this thing. Now what we'll do is we'll try to see how we can install and configure. So I don't think there is time so that I can parallelly catch up. It's not an online classroom training. So I'll go through these steps, but what I've done is for the interest of time, I've done these steps at least. So what we do is we go to this site and you download a Hive release compatible with your Hadoop installation. So if it's 0.20, then I think whatever the latest one will work. Then you untar it into a directory. That directory is your install directory. And set it in the bash profile. So I'll show these things. It's better to go through the steps. So this first step is done. I've downloaded it, I've untarred it, and I've done these things also. But what I'll do is I'll open the bash profile and I'll show how this is put already. So basically, the idea is the path environment variable should be able to find your bin directory. That's the basic in any installation. Otherwise, your executables will not work. So we do that so that we can run executables from anywhere. So this Hive install is not the best name I could have put. It should be Hive Home, but yeah, it's a mistake. It doesn't matter because I'm putting Hive install here also. So let's go and see where we can So I'll go to the root and I'll say so please stop me if you have anything to say, or yeah, if you have anything to please unmute yourself and talk about it. This is the give me one second. This is the bash profile where I've done stuff for this thing. So if you see Hive is here. So we have a Hive install variable which points to where I've installed Hive. So install in lab install Hive. Then there is a path. I mean basically appending the previous paths with Hive install /bin. So that's done. Okay. So this part is done. Now we can verify the installation of Hive by typing Hive and we can enter the Hive shell. So let's do that. So okay, one step before this is all the Hadoop daemons should be running. So daemons is as in all the Hadoop processes that necessary to run Hive should be running. So I have already have them running, and as a result, I'm able to get into Hive shell. So that's a prerequisite. That's understood because Hive is running over the HDFS Hadoop layer, so that better be running for it to work. So I basically am happy with this. I'll go